Hey guys, BuildZoid here, and today we're going to be taking a look at the HD7970 Matrix Platinum from ASUS ROG. And I got this card as a bit of fan mail, so huge thanks to the guy who sent it over, because these are kind of rare, and when you do find them, kind of expensive, but most important of all, these are freaking awesome. Partially because they're HD7970s, and 7970s are awesome in general, and because this is a proper Matrix card. Unlike, say, the most recent 2080 Ti Matrix, which is basically a gimmick strapped to a Strix PCB. So that makes this not just like a regular 7970 pretty awesome. This, however, freaking awesome because it is a Matrix. And what the Matrix, well, the funny thing is so the Matrix series from ASUS is basically like the ASUS version of like MSI has the Lightning series, which went the same way as the Matrix series, in that the most recent Lightning is just a massive disappointment as far as I'm concerned. Well, Gigabyte used to have the Super Overclock series, that's gone. Well, EVGA has the Kingpin series, and before that they had the Classified series, and then Galax has the Hall of Fame series. So this is basically one of those, cards targeted at extreme overclocking, and the most recent Matrix isn't, but this one is. And for the most part, that means we get some sort of cool overclocking features, and of course, a awesome VRM. And my favorite part of this card is definitely the VRM, because a lot of the features that like Asus added to the card, they're honestly kind of like, I can kind of like they seem like a good idea, but not implemented to the extent that I would like to see. So anyway, let's get into it, and starting off with the various features that, well, the thing is, they didn't add all of them. So, like, the dual BIOS, that's just a standard HD7970 feature. Unless you're buying the most down-costed 7970 you can find, your 7970 should have a dual BIOS switch, because that's part of the reference design for those cards. But the things Asus did add, they added a full speed fan button, which is kind of neat. If you're, if you're just testing out cards on air cooler, or if you're just benching on the stock air cooler, then that's actually a nice thing to have, is a full speed fan button, which sounds like a really minor thing, but it's just convenient if you're running benchmarks where, on desktop you can be at normal idle fan speeds, and then when you hit run in 3D Mark, you can mash the full speed fan button, and you don't need to worry about, like, you get as much cooling as you can out of the air cooler. Then we have this plus and minus button here, and this is one of those things where it's like, I wish they had this could have been so much more, so much better than what they ended up doing with it, as far as I'm concerned. So the plus and minus button here are basically just to slightly raise the core voltage up and down. It doesn't have a lot of range, and it only controls the core voltage. From my research, basically the range on this is from 1.27 volts to 1.34 volts, which is just kind of like, that's kind of pointless. And the thing is, it is just for Vcore, so it's like, well, what if I want to change the memory voltage, or the memory controller voltage, or the PCIe/display drive rail voltage, or the there's also a 1.8 volts rail, though as far as I know that one really doesn't do anything. So it's like, if you want to change any of the other voltages on the card, well, this is pointless. And even for Vcore, it's just not that great. So, yeah, honestly, not really. Like, I feel like if they had added a third button to this, so that you could cycle through which rail you're actually controlling, and there wasn't there wasn't actual limits on how far you can raise the voltage, that would have been awesome, because that basically would have meant now you don't have to use GPU tweak, and GPU tweak is trash. So, like, basically any kind of hardware level feature that means I need to use less garbage overclocking software, the happier I am. And this is like, this is like, this is hinting at, like, there was a possibility to have physical, like, hardware level voltage control for the entire card, and Asus just kind of did it for Vcore, and I'm just sitting here now like, well, that's kind of pointless, isn't it? Because, Vcore, of all the voltages as well, like, Vcore is the one that you're generally going to have the best support for in software anyway. So it's like, that's kind of pointless. Yeah, there's some, hardware level voltage control right there for the core voltage, which is just like, oh well, whatever. Below that, we have a safe mode button, which I assume is a workaround for GPU tweak being terrible, because I can't think of any other reason to have a safe mode button on a GPU. Like, it just doesn't make any sense. So the thing with GPU tweak being terrible is that um, I'm not sure if if Windows 10 might have fixed it unintentionally, but at least when I first started using GPU tweak, the biggest issue with the software is it had a tendency that if you crashed out of a benchmark with an unstable overclock, you wouldn't be able to get into Windows because GPU tweak would force apply that unstable overclock before you even load it into the system. And as part of the driver initialization, the GPU goes to full 3D clocks. So if you had GPU tweak installed, and actually I don't think it was even GPU tweak starting, like it just did something to the drivers where essentially there's like a file that I can't remember where it was located, but there was a file that you could delete from like Windows safe mode, and then you wouldn't have the problem. But well, you wouldn't have the problem. Like you could get back into Windows, but if you didn't delete the file, basically you'd get to the Windows loading screen. The GPU would initialize the drivers. It would go to the unstable overclock. It would crash, and you would never make it to desktop. And the easiest workaround for that, because the file is some obscure file somewhere in like I don't know where. So the easiest workaround for that was to just reinstall the AMD drivers. So so I assume this right here is a workaround for that stupid behavior of GPU tweak where it's just like if you crash out of the benchmark, then you're not getting into Windows anymore because GPU tweak is trash, which is a real shame because like ASUS adds the GPU tweak does offer a bunch of extra features for a card like this. So it adds VRM switching frequency controls. It adds a LLC on. Well, it's not really LLC. You have a VDroop on off. So essentially, you can turn all of the VDroop off, and you can have the VDroop turned on. There's no actual tuning option. It's kind of like a lot of older EVGA motherboards where you can turn the droop off, or you can have the droop on, and there's no in between. Like you can't actually you can't calibrate it, right? That's kind of the thing with load line calibration. It's not so much that you're calibrating how much droop you have. But then there's the on-off switch for VDroop, and that's what this card has, which admittedly for 7970s can actually be kind of helpful because they can sometimes have some weird issues if you let them sit at a really high voltage. That I ran into with one of my other 7970s where it was like once it was in a benchmark, it was fine. But it couldn't idle at high voltage, which was really strange. And the VDroop was really annoying as a result of that, because obviously the more VDroop you have, the higher your idle voltage is. So, yeah. Anyway, what else was there? So, so this I assume is just a GPU tweak workaround. Then this header right over here, I think it's this header. It might be this one, but it's probably this one. It actually doesn't matter which header it is, but the heatsink the heatsink shroud for these GPUs has a RGB load indicator. Actually, I don't think it's RGB because it only cycles. Actually, no, it does do green. So, yeah, okay, it does go green, so it has to have RGB. So they have an RGB load indicator. It's just that it never does yellow or orange, right? Which, in my opinion, is a huge disappointment because orange is the best color. No, but the load indicator basically cycles through red, purple, blue, and green, and it's just well, that's disappointing. So they have an RGB load indicator on the card, which basically just shows how much load the GPU core is under. And that's actually a pretty useful feature to have. It's just a real shame that they integrated it into the heatsink shroud, because if you swap the cooling system for a water block or an LN2 pot, you no longer have the load indicator, which is and the thing is, I really like the idea of having a load indicator like that because, Vegas come with it, Furies come with it, and it's super convenient for troubleshooting crossfire setups or just any kind of general overclocking issues that you might run into. Just you can look while the benchmark is running at the load indication LEDs on the GPU and see this GPU is not running the way it's supposed to be for whatever reason based on, the behavior of the load indicator. So it is actually something that I would have really preferred if they had just a strip of LEDs on the edge of the PCB or instead of this LED strip right here, because this LED strip right here is just for, these voltage control, is just to indicate the voltage level for these controls. which is just like, but this is already kind of pointless. So, yeah, load indicators are cool, but I really wish they had actually like a PCB level one. And it could have been like a secondary load indicator, because I get it, they wanted the big fancy colorful matrix word on the shroud, but a PCB level one would have been nice as well. Just, and that one might have had like a switch to turn it on and off. And the thing is, you might be like, but Buildzoid, all of this adds extra complexity to the PCB. They added freaking silly voltage control buttons on the card. This is not a concern. Like, the manufacturing cost of this GPU is not really a concern. This was also, I think, even more expensive than a 7970 Lightning. This was one of the most expensive 7970s you could get. There, as far as I'm concerned, no reason not to have things done better, in my opinion, at that point. It's just like, because this thing's not going to be cheap anyway, so who really cares that there's going to be a couple cents worth of, extra LEDs to replicate the functionality of the load indicator from the shroud onto the actual PCB. Anyway, on the back of the card, we get some more overclocking features. So there's an LN2 mode jumper. Then we have enables for the various GPU hotwire functions. So GPU hotwire is basically it's basically just a voltage hard mod, but it's done more conveniently, where ASUS makes sure that it's compatible with with some of their own motherboards and the OC panels that they put out. And so on this card, yeah, you basically have an LN2 mode, which I think just disables, well, I assume that basically enables the hotwire option and disables some kind of safeties. The issue is, a lot of the time, getting information on a lot of this sort of extreme overclocking functionality several years after the hardware has been released, very difficult, because all of the forum posts about it just kind of disappear, and it's not available in the official sort of marketing materials, because all of this stuff just completely, voids your warranty. So it's just like, the undocumented features are kind of the name of the game for a lot of extreme overclocking stuff. Which I find really annoying. Like, sometimes that makes me honestly prefer like reference cards to the extreme overclocking cards, because at least with the reference card, especially in Nvidia's case, instead of worrying about finding the right version of the voltage control software, you just hard mod all of your voltages, and you don't have to worry about like software compatibility or having the right LN2 BIOS. No, you just remove the power limit in hardware, you remove the voltage restrictions in hardware, you remove the like every single thing that could possibly be done by software, which you may or may not get your hands on, do it in hardware. Much more convenient, much more reliable. It can't break because it's physically on the card. Unless you, of course, like screw it up and then destroy your card. But I prefer it that, like, for me, that's that's far more reliable than the adventure of, I wonder which version of like MSI Afterburner I need for this card, or in the case of this card, I wonder which version of GPU tweak works best with this card, right? That kind of thing. So, yeah. Anyway, so we have these pads for enabling the hotwire functionality, and then these are actually connectors for the hotwire. And unfortunately, it's not fully implemented on this card. So they have hotwire for your memory controller, memory voltage, and core voltage. And funnily, and GPU tweak also adds the ability to control the 1.8 volts rail. But for whatever reason, there is no control for the 0.95 volts rail, which is kind of very important on 7970s, because that one moves the cold bug around. So basically, you can run them at lower temperatures if you increase the 0.95 volts rail up. And it also solves black screen issues that 7970s have if you're running very high core voltages at like low temperatures. So yeah, the thing is just like, but the thing is like, that's actually an issue for most 7970s. It wasn't, as far as I know, it wasn't until the 290X Matrix that there was any card with the 0.95 volts rail actually like voltage controllable in software or otherwise. Like, it just wasn't a thing. Like, when the 7970s when the 7970s first came out, like, it just was, like, even the Lightning, you need to hard mod the 0.95 volts rail, and you need to do that on basically every 7970 there is, which, yeah, that kind of sucks, but, yeah, it is what it is. So, but still kind of like wish this card had that. Then we also have voltage read points for like 3.3 volts ground and 12 volts, which is just, I don't like, I'm not entirely sure why you would need those because those are basically just those are those are voltages you would be checking if, you know, the card doesn't work anymore. So it's just, yeah, not really that useful in my opinion. There's also LEDs to indicate that the PCIe connectors are plugged in. And I think that's it in terms of features on the card. And to implement like the voltage control and the safe mode button, ASUS had to add an entire microcontroller, which is why we have all of this lovely circuitry up here. So, yeah, it's like, considering how far they went to implement like it's just like, why go that far? Like, this is a pathetic implementation of core voltage, and this is what you needed to do it, and I'm just like, why bother at that point? Like, if it would have probably, like, you would have been just it would have been just as well if that wasn't present on the card at all. But, you know, so enough complaining, because I did mention that these are awesome. And, well, this right here is a whole lot of awesome. This is, as far as I'm aware, well, yeah, as far as I'm aware, this is the most powerful Vcore VRM you can get on a 7970. And it is a 16-phase, and it is controlled by this chip right over here, which ASUS would have you believe that that's called an ASP1211. That's what it's labeled, at least. But this is actually just a CHL8228G, which is the standard voltage controller for it's the standard voltage controller for HD 7970s, because AMD just likes really high-end voltage regulators for some reason. That's an 8-phase controller, and at the time, I don't think you could really get a better VRM controller. So, yeah, like, there's nothing wrong with this, but at the same time, you also get this on literally every 7970 there is. Now, how do you get from 8 phases to 16 on the, 8 phases on the controller to 16 on the VRM? Well, you rely on these lovely chips right here, and those are IR3598s. Also, I failed to mention that this can go up to 1.2 megahertz switching frequency, and you can control the switching frequency from GPU tweak. And also, you can turn off the LLC on and off, which is, you know, part of the feature set of having a high-end controller. Because if you had a more basic controller, you may find that there's no LLC settings whatsoever. Or if you're NVIDIA, well, yeah, like if you have a lot of NVIDIA cards out there, it's just like the controller just doesn't support software level LLC control. It's done with resistors, which honestly, again, you know, if you don't want to deal with the potentially buggy overclocking software of the vendor that made the card, that can actually sometimes be better, in my opinion. Anyway, so that's the, you know, that's an IR3598, which is a dual driver with an integrated doubler. The doubler is optional, but of course here it's actually being used because you take one PWM. So basically what I mean by it's optional, you can feed 2 separate PWM signals into each of these chips, and then they drive 2 separate phases based on the 2 incoming signals. Or you can just run one PWM line in, and then you have 2 it takes that signal and it interleaves it between the 2 phases. So that's how you go from 8 phases to 16 through the 3598s here. There are like motherboards and GPUs which actually use these as just 2 drivers built into one chip because, well, instead of having 2 chips, you have 1 chip. But yeah, here it's actually also using the optional doubler function. And then for the actual current handling, we have these lovely MOSFETs right here, and these are Texas Instruments CSD 87350s, which ASUS absolutely loves using. There is so many motherboards, GPUs, and yeah, well, that's about it, right? Because yeah, ASUS doesn't. Well, I don't know. Maybe they put them in laptops as well, but actually, they probably put them in laptops too. But yeah, CSD 87350s, these are dual NFETs rated for 40 amps, which is kind of interesting because you don't normally, like a lot of other manufacturers of dual NFETs, they'll just, they won't give you an actual, like, they can't, that's an actual like power VRM application rating, whereas a lot of other manufacturers, they'll just kind of give you like a maximum drain current rating for the low side and the high side based on the case temperature, whereas TI is actually like, if you build a VRM with these design parameters, these can handle 40 amps. So it's a lot like a power stage in that sense, where power stages are rated based on actual, not necessarily with the same thermal constraints in mind, but an actual like current handling capability that, you might achieve in a real design. Whereas with a lot of like discrete MOSFETs or more basic dual end FETs, it's just kind of like, well, if you keep the case temperature at 25 degrees somehow, it can handle 100 amps. And then it's like, how do you keep it at 25 degrees with that much current going through it? Well, that's the very difficult part to deal with, right? Anyway, so we do have, these 40 amp dual end FETs, and that does actually mean that per phase, this is not the most powerful 7970. It just has the most phases, which, both ways are perfectly valid ways of getting a high current handling capacity. If you wanted a 7970 with the most powerful individual phase, you'd be actually looking at the 7970 VaporX 6 gig or the 7970 Toxic from Sapphire, because Sapphire came up with a great idea of putting two very low RDS on low side MOSFETs in parallel in each phase, which, yeah, I mean, that essentially gives the VRM just like basically the low side MOSFETs handle roughly 90% of the current flowing through the VRM. So at high currents, if you drop the resistance of the low side MOSFETs in half by just using twice as many of them, you end up with a lot of current handling capability. And then if you look at the MSI Lightning, well, the MSI Lightning basically is a 14 phase, and it actually uses the same MOSFETs that Sapphire is using, but it doesn't have two of them in parallel for the low side. So yeah, you don't get the same sort of, ridiculous per phase current handling capacity that Sapphire gets out of their design. And here, but this design right here, we just have a lot of, and this is not a bad rating, like for each for a dual end FET. Like this is a really nice MOSFET right here. So yeah. But ASUS's solution to the how do we get more current handling capacity is just go for 16 phases. And there's honestly, like, one of the benefits to going with this style of design is it does mean, like, you have lower inductor losses, though admittedly you can get, higher current rating inductors as well, depending on what you're doing. And also by like going for 16 phases, well, you spread the heat over more area, right? Like if you look at the Lightning, it basically is a straight line of 14 phases, and so potentially right around the middle, it's going to get very, very hot. And if you look at the Sapphire card, Sapphire's VRM is like jammed into as little space as possible. Like where both the Lightning and the Matrix have these massive like height extensions to fit their power delivery, Sapphire somehow managed to squeeze that 8 phase onto a relatively standard height 7970 PCB, and it's just kind of like, well, that's gonna be great for thermals, isn't it? Yeah, like this right here honestly should be the easiest to cool VRM that you can get on an extreme. Well, the thing is, the Sapphire cards aren't really meant for extreme overclocking. They just have a really great VRM on them, and then they have awful software voltage control support, which is just great. That's a real shame. But yeah, this right here, basically, you have a lot of current handling capability in the MOSFETs, and then you have it spread over a lot of surface area. So in terms of cooling, this should actually probably be the coolest running of the 7970 VRMs there are. And in terms of efficiencies, so 1.3 volts output voltage, which this is just a convenience thing. That's what the data sheet is spec'd in. It's not like it changes significantly if you're looking at 1.2 volts or 1.4, and 1.3 volts is actually a totally reasonable voltage for like air-cooled overclocking on a 7970. So 1.3 volts, 500 kilohertz switching frequency, and 5 volts drive voltage, which I'm not sure that this is necessarily running on 5 volts drive voltage, but these are kind of optimized for 5 volts. They can get a little bit more efficient and high current outputs if you run them on like 6 or 7 volts, but there's no, like, the thing is there's no actual option to control the drive voltage in the GPU tweak software, which, like, ASUS could have implemented that, but they didn't. So, and it's honestly, like, I don't think it's a big deal. Like, this is a freaking 16 phase. It's not going to have a problem, as you'll see. So 160 amps output, at 5 volts gate to source voltage, this VRM is going to be producing 19 watts of heat. At 240 amps, it's going to be producing only 30 watts of heat. And again, like, that is spread over a very large amount of PCB. So, that just further improves the thermals of it, because 30 watts is actually a pretty significant amount of heat. then going up to like 320 amps. And so also for like air-cooled to water-cooled overclocking, you'd be sort of looking into this range in terms of currents, like up around to that 240 amp level. 320 amps, you'd probably starting to look at like dry ice. Yeah, now you'd be looking at like dry ice cooling, maybe some like low voltage liquid nitrogen overclocking, but what's the point of low voltage on liquid nitrogen, right? Anyway, so 320 amps, it produces 45 watts of heat. 400 amps, it'll produce 63 watts of heat. So at this point, you definitely start, having to force airflow over the VRM, and as you keep shoving more current through it, then obviously you're going to need even more airflow. So 85 watts and 560 amps, you top out at 111 watts. And I don't think 16 times... actually that is, isn't it? No, it isn't. Wait, 560? How the hell did I get 560? I'm wondering if that's not supposed to be 540. 5.6 divided by... Oh no, that's just 35 amps. Well, yeah, that's the thing is, oh right, it would have been 640 for 40 amps per phase. So, you might be like, well, why didn't you go all the way up to the 640 amps per phase, considering these are 40 amp dual NFETs? Well, that's the thing is, like, at 35 amps through each of these phases, you're looking at the MOSFETs producing 111 watts of heat. Like, theoretically, if you had like a small air cooler strapped to the VRM, you could run 40 amps per phase. Practically, not really. So that's kind of the thing with a lot of, and this is true for like power stages as well, is like if you have a 60 amp power stage, that doesn't mean if you put 8 of them next to each other, you can run 60 amps through them. No, it means if you have one of them and a very big heatsink for it, you can probably push 60 amps through it. So, yeah, that's kind of the thing, is just like, per phase is not that useful when you realize that you have a lot of the phases jammed together, but it does help that the layout here does help significantly with the thermals by just spreading the heat over more area. Now there is a downside to the sort of having one row of Vcore and then another row of Vcore VRM layout, where essentially the power going from the second row is like there's more power loss through the power plane going that far. Also, GIMP is being weird. GIMP, why can't you just be normal for once? Okay, now it's back to normal. Good. But yeah, like this is actually still one of the most powerful VRMs on a 7970. In terms of efficiency, and then because it takes up so much space on the PCB, I'd argue it probably has a thermal advantage against all of the other designs out there, because like MSI's VRM is relatively high density, and then Sapphire's is just like, watch this MSI. This is how you do high density, where they might like their PCB is not much bigger than a regular 7970. It's really concerning actually, when you consider how much how much current you could potentially push through one of the through their VRM if you looked at just the specs of the MOSFETs, and then it's like, yeah, but that heat is going to be squished into a very small PCB. Anyway, so yeah, power output wise, I'm a huge fan of this VRM right here. Things I'm not a fan of is the capacitor configuration, actually, because ASUS, like, they didn't really do anything special. There's a lot of other extreme overclocking cards out there where you'll just see, a massive amount of SMD aluminum polymers or, tantalum capacitors on the output of the VRM for filtering. ASUS just kind of went with a bunch of, like, again, their top-end, Nichicon FP series capacitors. At the same time, they're also rated for 10,000 hours, and the general trade-off between endurance rating and ESR is the more endurance rating the caps have, the worse the ESR is. So, yeah, I'm not really, these are fine. I would have preferred to see, like, maybe more ceramics or just, it just makes me wonder. And this is this is the main reason I'd really like to get my hands on a 7970 Lightning, is because, for the 7970 Lightning, MSI went for all SMD aluminum polymers as their bulk output filtering capacitors, whereas ASUS here, they're going for through-hole aluminum polymers, which are 820 microfarads each, and then rated for 10,000 hours. So these are really like high endurance, but it's just like, I don't think they're the best at suppressing transients. Like, or at least, it's not even like, they're just generally not the best for suppressing high frequency switching noise. So, and by that, I don't mean what the VRM is producing, because there's 16 phases being interleaved at potentially like 600 kilohertz per phase, considering you can go up to 1.2 megahertz on the controller. So, the switching noise of the VRM itself is not the concern. It's just like, but when the core goes through a transient, like, these capacitors are just not particularly fast. And then looking at the back of the card, like, I would honestly looking at this right here, I'm kind of strongly considering stripping off the solder mask and adding capacitors, as just, and then testing if that actually leads to any improvements. Because I do have a lot of 7970s, so I do actually want to do like comparison tests between the ASUS VRM and like the Sapphire VRM, and then the other Sapphire VRM, and then actually, I have 3 different iterations of a Sapphire VRM for it's one of them's a 280X, but that's still basically a 7970. Actually, not even basically, that's just a rebranded 7970. And then there's also, I have the power color card with a bunch of extra capacity. Is it a power color? I have some 7970 with a red PCB and a bunch of extra capacitors. So I want to test that as well. Yeah, so basically, and I'd like to get my hands also on a 7970 Lightning and just do a comparison between all of them, because I don't think, like, there's definitely, like, this should definitely be, like, a reference 7970. I don't really see any way this could lose to, like, a reference 7970, but reference 7970 designs are not exactly what I would consider quiet VRMs. They're not great. Like, from because I have done scope shots of those, they're not particularly impressive. But compared to something like a Lightning, I would have to make the assumption that this just loses to a Lightning, when it comes to transient response and that kind of thing. And then the Sapphire VRMs, I have no idea, because those are just very strange in many ways. Sapphire does have one version that has a bunch of SMD capacitors, so yeah, it'll be interesting. But yeah, once I get that testing, I'm strongly consider, like, you could totally cram a capacitor like that, and okay, there's not really any space over there, like there, and there, and there. And if I get creative, I can totally put like a bunch of ceramics in this area. That's no problem. There's plenty of space for those. So yeah, I'm not really, and then like they didn't do anything special behind the core, which like MSI has the silly like reactor thing for the Lightning, which I'm also not really a fan of how that's implemented. It's a good idea. It's just like the fact that it uses those skinny little connectors is just like, that probably negates a lot of the benefit of those capacitors. But yeah, so very powerful VRM, but I do wonder about, like, I think on voltage regulation, MSI might ultimately have the win. Now, for the memory power delivery and the memory controller power delivery, we're like this. So, memory controller is this right here. Memory is this right here. Both of them are two-phase design. Both of them designs. Both of them use controllers that I can't identify for the life of me. They have really obnoxious, like, there's a bunch of controllers that show up on cards which have basically like really obnoxious markings on them where it's just impossible to find data sheets. Yeah, these are 2 of those. Yeah, 2 phases for each of those, which for comparison, I think the reference 797, well, actually, it's kind of interesting. You can get 7970s and 7950s with a 2-phase memory controller VRM, single-phase memory, or you can get single-phase memory and single-phase memory controller for sort of like a reference. There's kind of 2 options for a reference PCB for those cards. But here we obviously have two phases for both. The memory controller, in terms of output filtering, not really anything that special, right? We just have, well, upgrade over the reference card, but that's not really a surprise. I don't really think this is too critical. Like, I'm not sure. Well, yeah, I've not actually gone and scoped a memory controller yet, but I should probably do that. For the memory, we do see some nice additions I like to see, which are mostly on the back. Like these right here, those are good. Um, so it does look like ASUS did some extras for the memory, but didn't really do anything for the actual like for the memory controller. And then for the core, yeah, this is pretty standard Vcore. So yeah, that's the thing. Kind of disappointed by the output filter for the Vcore. Memory looks fine. It could be better in my opinion. Again, like MSI's Lightning, the 7970 Lightning, like they just went to town on it with the capacitors. Whereas I feel like ASUS basically went like, we're gonna go for more power handle, like a better thermal design for the VRM, and then a bunch of silly junk on the edge of the PCB that doesn't actually do anything, and then workarounds for our garbage software. And GIMP is not working again. I am very annoyed by that. So, anyway, at this point, it might be like, Buildzoid, could you stop complaining about the card? Didn't you say it's awesome? Well, it is awesome. This VRM, awesome. The rest of it, kind of like, it's a 7970, right? Which, again, is very awesome, but, like, yeah, it's just different priorities in terms of design with like this versus some of the other 7970s. Well, a lot of other 7970s are just like make it as cheap as possible, which you can get 7970s with four-phase Vcore, which is actually really concerning. And it's actually such a massive problem that those cards come with BIOSes that have the voltage control disabled, because if you overvolt those VRMs, those four phases generally can't handle that. So no voltage control, right? It's just like if you build something with very low quality, just make sure nobody can adjust the power limit, and then you don't have to worry about the quality being so low. Anyway, I didn't mention the actual MOSFETs used in the memory controller and memory, so that's MEM. And this is the memory controller over here. So the MOSFETs used in these, we have two low sides in parallel, and then a high side MOSFET, and these chips also integrate all the drivers for the phases, so that's why you don't see like an extra chip for driving the phases. The high side MOSFET is a PH 7030AL from Nexperia Semiconductor, and the low side is a PH 5030AL, also from Nexperia. How very surprising, right? And yeah, these are completely fine for this. The thing is, the memory, like I've actually measured the memory and memory controller power consumption on a 7970, and what's kind of interesting is that they both pull about 15 watts, even when overclocking. And however, the distribution of like voltage to current is very different. So memory runs on about 1.5 volts, whereas the memory controller runs on around 1 volt. So this is 15 watts where it's 15 amps at 1 volt, and this is 15 watts where it's 10 watts at 1.5 volts, which is just kind of like interesting that it just lines up like that. Yeah, so this, like, you don't really need a ton of current handling capability for either of them, because, yeah, it's not really that much current, and if anything, the memory controller actually pulls more current than the memory itself, which is just kind of interesting. And I think that's generally the case with most AMD GPUs, that the memory controller is actually pulling more current than the memory itself. So, because if you look at a lot of AMD, like, reference PCB designs, the memory controller VRMs tend to be more substantial than the memory power delivery. So, yeah, and in this case, like, basically ASUS has a two-phase for both of them, and they're, the same VRM twice, but both of them are massively overkill, so it's just fine that, they didn't, like, they don't need to make one slightly more powerful because they're both overkill for either application. So, yeah, that's kind of it for the 7970 Matrix. It's like, I love the Vcore VRM, and I will admit, like, being able to control the switching frequency and GPU tweak is cool. The LLC on-off, well, not LLC on-off, VDroop on-off is cool. That's a cool feature to have. The heatsink on this is actually really nice as well. It's not that, like, does a good job of cooling the card. Yeah, in terms of the like the capacitor configuration, like yeah, they're high endurance through hole Nichicons. I would prefer something where, like the thing is, the SMD polymers, like you actually can't really get them in really really high endurance ratings, as far as I know. I've only ever seen them at like at best with like 2,000 hours at 105 degrees, whereas these you can go for 10,000 hours at 105 degrees. So you know, it's just kind of like I don't know. In terms of electrical performance, the low endurance ones are better. So, and with like with a VRM, like if the VRM runs really cool, then and you also have a good cooling system for the rest of the PCB, then the whole high like because high endurance at high temperatures is like, well, just don't run the hardware at high temperatures, and then you don't need the high endurance capacitors, right? Like better solution to the problem in my opinion. But yeah, so that's the Matrix. A whole lot of VRM and then some kind of gimmicky features. Um, but yeah, um, like I'm excited to have the card because it's a freaking Matrix and like a proper Matrix, not like a lot of the well, not like the 2080 Ti Matrix where that one's just a massive disappointment. So yeah. That's it for the video. Thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. Once again, thanks to the guy who sent in the card because I know I've complained about so many things, but I do legitimately really like the Vcore VR. Like, I can fix the capacitor configuration. Fixing the MOSFET, like fixing the controller or MOSFETs or that kind of thing, much, much more obnoxious than attaching a couple extra capacitors. You know, so if there's not enough caps, that's fine. But if there's not enough if there's not enough phases slash MOSFETs, that's very not fine. Yeah, and what else did I want to do? Oh, right. And if you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the HOC Teespring store where you can buy shirts, stickers, posters. It achieves the same thing as the Patreon in terms of like supporting the channel, except you get like a shirt or something in return. And I guess since I did mention that this is fan mail, some people might be like, BuildZoid, I want to send you my old dead slash not in like hardware I have lying around in my closet gathering dust. In which case, leave a comment down below. I will comment what it is that you actually want to send in because I am not willing to just accept anything because I'd be flooded in like not like I like honestly right like already I'm kind of running out of space, but if I just took everything anybody wanted to send in, then I'd basically end up probably being like a recycler for e-waste because yeah, it's just like there's a lot of GPUs out there that are gathering dust in people's closets and there's a lot of them that will like I'm not interested in. So you're gonna have to mention what it is that you want to send me before I give you a PO box address. So you know, if you're interested in doing that, leave a comment. And yeah, that's it for the video. So thanks for watching and goodbye.